Hello and welcome to this video on binary search in Java. In this video, we'll be seeing about what is searching, the different types of searching, and what is binary searching and how to perform them, and the inbuilt module available in Java to perform binary search. So binary search is used to search a key element for multiple elements. Binary search is faster than linear search. So in case of binary search, array elements must be in ascending order. If you have an unsorted array, then you have to sort the array using arrays.sort arr method. So coming to the binary search, let's dive into the let us dive into the coding part. So here we have a class test main and a public static void main setup. So first, let us understand what does searching mean. I'll have a array variable of int, and I'll assign some values like 10, 20, 30, 40, 50, maybe. Yeah. Now, if I want them to, like find the element 30, so I'll just be like, write a for loop int I is equal to 0, I less than a dot length, and I plus plus. And I'll just check using if condition if a of I is equal to maybe 40. And if it is true, I want it to print and found. So this is my code. Let's check if the code is running. As you can see, it is able to print find. So it is able to find the element 40. So this is called as linear search, where I'll perform a loop and check each element if it is equal to the element that I want it to be compared with. So the problem with this is it's gonna take n times long, meaning it has to go through until end of the loop. So here, if you look closely, our array is sorted. So when it comes to sorted arrays, we can use a certain concept called binary search, where you can limit the number of elements that are being checked. So how do we do that? So as you can see, our first element is 10 and last element is 50. For element to be 40, I'll try to find the middle element of this array, which is nothing but 30. And I'll compare 30 with 40. And if my value 30 is greater than 40, it's not true. And I'll check if 30 is equal to the value of 40. It's not 40. At last, we'll also check if 30 is less than 40. Less than 40 is true. So what I'll do, I'll make my array initial element of the array as 30 and the last element as 50. Now what I do, I'll try to find the middle of these two elements, which is nothing but 40. Now I'll compare and I get it up. So what happens, I try to minimize the number of elements that are being compared by reducing the array into half and half and half and so on. So by doing this, what happens, I'm limiting the number of elements that I check, and the time to find the element is also quicked up. So how do I do that? I'll try to create a new method to solve that. So I'll have a public static element void binary search. Let me name it as binary search. And inside this, I'll have certain arrays. Array A, and I'll have my first element. I'll have my last element, and I'll have my key. Key is nothing but the element that I want to be found in the array. I'll just remove these code. So now what I do, these are my parameters that I get: the array, the first element, the last element, and my key. So first I try to find the middle element of this array, which is nothing but int mid is equal to first plus last divided by 2. So by doing this, I get the middle element of my first and last array. So by performing mid, first and last divided by 2, I get my middle elements. location. So my first will be default 0 and my last would be a dot length minus 1. So let me initialize it here first. In first is equal to 0 and last is equal to a dot length minus 1 and our int key. We'll assign some value, like maybe let's find 30. And I'll just call my function binary search and I'll have my values a, first, last, and key. So let's move on. So now, since I found my middle element, I'll try to perform a loop. While loop. I'm using while loop because it helps me to loop until an error occurs, right? So I'll make sure my first element is less than or equal to last, because we are going to split it into one element, right? When your first and last interchanges, that means all the elements are checked and the element is not found. So this is our breaking condition. While it's breaking condition, what I do, I check first if a of mid is less than the key. The key element that I get, if it is less than key, I'll make my first element as mid plus 1. So if my a of mid value is less than key, in our example we had 40, right? Is less than 40. It's true, right? So now my first element, instead of 0, it becomes mid plus 1. So it's nothing but this value is not true, so I'm just moving it forward. So now else if this is not true, I check if my a of mid is the key. So if this is the condition, I'm going to print element found. And at last, else. If these both conditions fail, it means that a of mid is less than key, right? So now I make my last element mid minus 1. So now if my element is like 20 and my mid value is greater than 20, I just make my last element, instead of a dot length minus 1, to mid minus 1, which is nothing but mid is 30 minus 1. Yeah. So if I found my element, I need not worry further, right? So I'll just break this code to come out of the loop. So now I again perform the operation mid is equal to first plus last divided by 2. Now I'll have a last condition to check if this element is not found, our loops interchange, right? So I'll just write first is greater than last. My output will be element not found. Not found. So our code, we have our array, first element, last element, our key. Key is nothing but the element that we want to found. And we have our function here. We have called this function, and what we do initially, find the middle element of the array, and we check if the first element is less than or equal to last. Until this condition fails, we'll be looping. We'll find if the mid value is less than key, we increase the first element. Later we find if the mid element is the key, and we just print found and break the statement. Else we minimize the last value, which is mid minus 1. For each loop, we find the middle element because it often changes, right? Our last and first element changes, or mid value also changes each loop. So at end of the loop, if we had found it, we would have had the first value greater than last still. So only if it is lesser case, we'll have not found. Now let's try to find the answer. As you can see, the element is found. The value that we want to find was 30, so we found it in one iteration. What do I mean by that? So the middle element of our first loop would be 30, and our 30 would be associated with key and found. In our linear search, it would have taken us 3 loops to find out that 30 is the value that we need and it is found. So we are preventing 3 loops from happening. Same goes to the case of 50. 50. If I try to find the value of 50, what happens? 50 happens in the first loop itself. Found. So it also takes only one loop. So our first element is checked, last element is checked, and since our last element is found, we are able to figure it out quickly. So this is the use case of binary search. We can also perform this binary search using recursions, which is nothing but instead of finding first is equal to mid minus 1, I'll be again reinitializing calling binary search, but the values of first or last would be changed depending upon our loops. Our first is equal to mid plus 1 would be initialized here, or our last is equal to mid minus 1. For each loop, you'll be calling them out, and if our mid value is found, we just iterate back, and instead of break, we'll have a return statement. So we can either perform this, or we also have this binary function that can be called using java.utils. So we have our import file called java.util.arrays. In this arrays function, we have a function called as arrays dot binary search, and inside our binary search we have our array element and our key, and this would return us our results. So we need to associate this value with result equal to binary search. Now if our result is 0, less than 0, then our answer is not found. So we'll have our output as not found. If our result is not less value, we'll then have found. So let's just check if it is able to find it out correctly. As you can see, we are able to find the value 50. Now I try to print the value 30. If both values are same, our output is right? Found. When I try to find some value that doesn't exist, not found. So our inbuilt function also works. So you can either perform your own code or you can use your inbuilt function. I would prefer you to use your own code because you'll understand the nuances of the programming and try to understand it. And there are various variants available for binary search for your particular use case where you can perform exponential binary search and other stuffs. For that, you need to understand the fundamental algorithm that works behind binary search. So hope this video is helpful. In this video we saw about what is search, what is linear search, what is binary search, and a normal way of doing it, and how to use it using recursions, and at last the inbuilt function that is used to run it up. Thank you. See you in the next video.